we'll be going to discuss weekly contest 500. So yeah, it's a milestone for LeetCode that they have hit their 500 contest. So yeah, let's jump into the videos. So moving on to the first question, it was a pretty simple question, and we need to count indices with opposite parity. So the question states like we'll be giving an integer array nums this, and for each index we need to find score, and score for each index is defined as uh, like this. Okay, so let's suppose that I is some index, and so for I, all the indexes which are greater than I, so that is, we'll say it as j. So if I is here, all the things that lies on the right of it, right, those are valid index. And when are they valid? When do we add a score to it? If those nums of I and nums of j, they have a different parity. Okay, and for each I we need to return an integer array, what is the score, and hence for each index we need to store the answer and return it. Okay, so it's a pretty fair simple question, and the length is also 100, so we can do a double for loop, like we can do run a double loop for loop, and that will be answer. So my intuitions for this problem is like pretty simple. So for every index, let I is this, so I'll run a loop from I plus 1. Okay, and I will see if the parity of so my first loop runs for the this, let's say this first loop, and the second loop runs from I plus 1. So this is my j, and it will check if the parity of both the numbers are different or not. If the parity, so parity of nums of I and parity of nums of j, if the parity is different, we'll increment it, and for this particular index the answer will push it into our answer and we'll return it. So that was a pretty fairly simple question given the constraint, and it was an easy problem. So I hope it's easy, and I will jump forward to the next problem. But if you have any particular doubt, do feel free to reach out in the comment section. I'll be happy to answer. Okay, so this was the second question, and it says like sum of prime between number and its reverse. Okay, so let me explain the question. So we're given an integer array nums, or integer nums n. So let n be the number. Now we need to form the reverse of this number. So for this particular number, the reverse will be 31, right? And next thing is we need to count all the prime numbers that lie in the range of this particular number and reverse. So let's understand what this problem states. So I'll take this particular example, though it was fairly simple, but let's understand the problem, and then we can understand much better. Okay, so this is our array, this is our problem, and let's understand with the example. So n is given to us as 13, right? And we need to form the reverse. So reverse will be 31, right? Now we need to find all the numbers in the range minimum, all the numbers in the range which lies in the minimum of both. So minimum of this will be, which lies in the range L to R, okay, inclusive. And what will be L? L will be the minimum of these two numbers, that is 13 or 31. Minimum is 13, and R will be maximum of these two numbers, that is 31. So we need to find all the numbers, prime numbers in the range of 13 to 31, and the numbers that are in the prime number that are in the range of 13 to 31 are this. And finally we need to add all this number and return whatever is the score. So I hope the problem is explained clearly, and now we'll move forward to the solution. So what do you see, what all do I need, right? So if I am given a number n, right, the very first step I see, let me change the color and then we'll explain. So the very first step, if I'm given a number n, so I need to find a number reverse. So we'll need to find a reverse. So first is reverse function, right? So we can get the reverse, right? Now once we have it, now we'll form L and R. So L will be, so if this reverse is R and this is N, so L is minimum of N comma R, and R is okay, let it be, so let it be R1, okay, or you say reverse, okay, so this will be reverse, and R is equals to maximum of N comma reverse, right? So we have our range defined now. Now we need to run a for loop. I'll run a for loop, and for each number in the range, for loop I will run I that belongs to L to R. Okay, and I will check if I is prime or not. If I is prime. Okay, so what do I need? I need is prime function, right? Or I need to check if the number, if I'm given a number n or let's say if I'm given an integer I, is it prime or not. So I need to check if it is prime or not. And if it is prime, I will add it to my answer, right? And at the end, I will return the answer. So I hope we are pretty clear from our requirement from this, that what is our requirement for this particular problem. So very first thing is we need this reverse function. Okay. The next thing, this is a pretty fairly simple thing. We don't need it. And the second thing we need is we need to check if I'm given an integer I, whether it is a prime number or not. Okay. So this you can easily get it. So I hope you know, we have very Euclideans like the efficient way to calculate if a number is prime or not. But for this particular question, we can run a loop, and if a number is how do we know if a number is prime or not? You can check gigs for gigs, but it's pretty general. Like if a number is not if a number doesn't have any divisor, then it is called prime number. Okay. And if you see the constraint also, given n is less than 1000. Okay, so we can run a for loop to check if any number is dividing it or not. So but yeah, you can definitely check this prime function to know if a number is prime or not. You can search it in the other references. For this particular thing, I have to just run a for loop. Okay, so this is the very first thing. If you see the solution, this is the step one, which calculates if a number, it will find the reverse of a number. So for 13, the reverse will be 31. For 10, the reverse will be 1, right? The second thing is I will find left and right L and R, and I will initialize my answer as 0. Now I'll run a loop from L to R, and I will check if the number is prime or not. If the number is prime, I will add it to my answer. If the number is not prime, I will add 0. So if a number is not prime in this particular function, if a number is not prime, so it has got a divisor. In this case means there is another divisor which is dividing the particular number, so we'll return 0. And if the number is not, if a number is prime, then we'll return the particular number, and we'll just add it to the answer and we'll return the answer. So yeah, that was pretty simple, and I would think it was more of an implementation type problem because the constraint was very less than this. But yeah, you can definitely optimize this particular part if you want, by pre-calculating or something. Okay, so now let's move on to the third question. Okay, so yeah, even this was also an implementation based question, but yeah, let's read it. So we're given the integer array nums, and where nums is strictly increasing. So the very first thing we can take a note from is it's given it's increasing. So let me get a pen. I'll just download some paint tool so that I can write on this particular thing. Okay, so let's see. Okay, if I take this, right, so the very first thing that is given to us, it's strictly increasing, right? It is strictly increasing. Okay, okay, so this is the first thing. Now for each index I, the closest, so for each index, so we also defined what closest mean, right? So closest is, let's say for index, if I is here, so for as per this question, I'll just explain. It's better to explain it more, like it's getting a bit difficult writing here, so I'll better explain it in the particular whiteboard itself. So let's just read the question first. We'll take this question and then we'll see what actually it means. Okay. Okay, so we are given an integer array nums, and nums is strictly increasing. Okay, so nums is strictly increasing, so this is the first thing to note. First thing. Okay, and for each index I, let's say x, the closest, so we also define closest, what closest means. So closest of x is equals to, so if closest of x, so let's say this is in the index I, so there is some number here and there will be some number here. So the closest for this number will be either this or this. Okay, so whatever, so let's say it has so this will be let's say y, right, let it be x. Okay, and this will also be some y or something, right? So if this particular difference is smaller or equal to this particular difference, so let's say this distance is d1 and this distance is d2. Okay, so if d1 is smaller than equals to d2, then in this case the closest for this x will be this I minus 1. If this, then it will be I minus 1, else it will be I plus 1. Okay, so that basically that comes boils down to which distance, like whether this element, whether this distance is smaller or this distance is smaller. So whichever distance is smaller, we'll be keeping that index as the closest. Okay, and there is one case if both are equal, then we'll keep this smallest one. Okay, so this is the second thing. Uh, now okay, so now there's also something like we have defined some move, right? So this is defined as move. So let's say if you want to move from here to here, let's say some index, so you can move from this index x. Okay, and we need to move to y index. So if there are two options, if this index y, it is the closest of this x, so whatever closest that we have calculated for this particular x, if this is the closest, then we can move in one distance. If it is not the closest, then we can move in whatever is the value here minus this. So absolute of whatever is the value at nums of y minus nums of x. Okay, so this is the second thing, right? This is defined here. Okay, so this is the other part. Now we'll be given queries, left to right, q queries in the form of L to R. Okay, now and we need to return the answer, where L to R means the what is the minimum cost that in which we can reach from L to R for each query, from index L to index R. Okay, so okay, I hope the question is fairly explained. So let's see this example: -5, -2, and -3. Okay, so -5, -2, and -3. Okay, so and if you want to calculate the closest, right? Now, what is the closest for this particular? Let's calculate the closest so that we can understand what closest actually means. So this particular value, which number is smaller? So here, that it doesn't exist, so it cannot be. And on the right, which is the nearest value on it? So on left there is no option, so we cannot. But here, if you see right, so for this particular index, if it is 0, 1, and 2, so what is the closest for this? It will be 1, right? And for here, if you see, right, so there is two options. So uh, absolute of this distance -2 and -5. Okay, so this will come out to be absolute value since it's 3. Okay, and the other value will be, if I calculate this, so -3 minus -2, which comes out to be 1, right? So which is more closer? Here definitely you see this value is smaller. So whichever value is smaller, that index will be there. So for this particular index I equals to 1, the closest value will be 3. This one, index 2. So this will. And for this particular index, we see that there is no right. So it will be the only option we have is this. So it is 1. So from here, what I can say is for closest calculation, right? For index 0, right, the answer will be 1. Index 0, the closest will be 1, and for index n minus 1, the value will be n minus 2, right? I hope that is understandable, right? Now once we have this, what is the other thing we can do, right? So let's understand with this particular example, I guess that will be helpful to us. Okay, so I guess this will be easier to understand, and we'll get the intuitions as well fairly. Okay, so let's see. Okay, so once we have this number, right, so if we have this number, for this number the closest that we have got here, right, so if you see, it will be, if you calculate it for this number, it will be always 1, and we have 4, right? And for this number it will be always, since it's length 3, it's always will be 2. Now for this particular index, the difference is 2 and difference here is 1, so this will be the answer. So here it will be 2, right? For this one, if you see, the difference is 1 and the difference is 6, so 1 is lesser, so it will be 1, right? This particular index, right? So once we have the closest, now if we want to go from let's say if we want to go from this one 1 to 2, so 0 1 2 3, right? And if and what we have is nums, okay. So nums we see 0 2 3 9, and we want to go from 1 to 2, so here to here, right? So this won't help us because we already have, like, it can be reached in one step. Okay, but explain let me explain the intuition. Okay, so let's understand. If I have the closest, okay, I'll have some closest defined to me. Firstly, I'll pre-compute it closest, and the next step is, let's say I want to go from some index. Let's say from here L, I want to go to some index R, right? So there will be two part. First case when L is lesser than R, and the second case when R is less than R is lesser than L. So L is greater. So opposites. Okay. So let's first understand this case. Okay. So I want to go from this case to this case. So what is the way? See, if I want to go this, since the array is strictly increasing, right? If I move one step, let's say if you are moving from 3, here if you have 5, and here you have gone to 10. Okay. So if you want to go from here to here, the two options are, either you can go directly from here to here, that will cost you 10 minus 3, which is equals to 7. And the second option is, you go from here to here, that will cost you, either, it depends, like, okay, but for the first case we are assuming this is not the closest. In that case it will cost you 2, and from here to here it will cost you 5, right? So clearly if you see, it's costing us 7. So one thing is very clear, right? If you want to go directly, uh, jump directly, so whatever cost you get, right, it will be always greater than or equals to one step jump. And why I'm saying this is because, right here, if you see, you need you took whatever cost, two costs, right? You assume two costs, but what if this was the closest, right? If it is the closest, then in that case this two will become one, because it is given to us that you can jump to next index, like, you can jump to index y, which is closest, in just one cost, right? So what we are going to do is, we are always going to jump one step, and we'll check if it is closest, then we'll add a cost of 1, else we'll add a cost this if closest, and else case if it is not closest, right? So let me get a better example to understand this particular question. I'll just get a better example. Okay, so let's take this. Okay, if closest, else absolute of nums of I minus nums of I plus 1, and we'll iterate overall. So let's understand with this particular example. Okay. Okay, so for this particular array, right, we'll first form the let's say the nums 1 4 6 20 and 21, 1 4 6 20 and 21, right? And this is our nums array, and so our closest that we calculate is, right, for we know for this particular 0 1 2 3 and 4, so this is the array that we're calculating, and we'll see, right? So for this particular index, closest will be always 1, and for this particular index, closest will be always 3, like n minus 1. Now, for this one, if you calculate here, 4 minus 1 different 3, and there if you calculate on the right, it is 2, so hence it will be on the right one. For this particular index, if you see distance from 6 to 4, this and this, if you see this distance is smaller, hence the distance for this closest will be 1. For this particular index, if you see it is 1, and here if you see it's 14, so it will be 4. Okay, so now we have the closest. Now let's say we want to go from 0 to 4. Okay, so we want to go from here to here, right? So what is the one way to go? So the one way, if you go directly, right, here to here, so what will be the cost? So cost will be cost 1. Let's say if direct cost, it will be 21 minus 1, which is 20, right? The other way will be, so this is one cost. So this is one cost, and the other cost will calculate, right? So other cost is, I'll go one step and see which is better. So if I go from here to here, right? No, let me go. Okay, so if I go from here to here, what is the cost that I'm gonna take? Okay, since we know for this particular, if I'm going from here to here, the closest for this one is this one itself. So closest for this particular index is this, right? So I will take a cost of 1. So for this movement, I'll just form the array again so that we can understand, right? 1, 4, 6, 20, and 21. So if you see, right, if I go from here to here, if for this index we'll check what is the closest. So for this particular index, our closest is 1, and we are moving to the same index, hence it will take us a cost of 1. Now from this particular index, if you go from here to here, what is the closest for this particular index? If you see, the closest is 2, hence it will take us a cost of 1. If it was not the closest, it will take us 2, like 6 minus 4, whatever is the value, if it is not closest. For this particular index, if you see, if I'm moving here to here, what is the closest for 6? It is 2, right? The closest for this particular 6, what is the closest? It's 1. So it is not this. Okay, so it will cost us this 16 minus this 20 minus 6, which is cost us 14. And for this one, since it is the closest, it will cost us 1. So if you see here, the value is 1, 2, 3, and 4. 14 plus 3, which is 17. So we always see, like, it's always better to go one step rather than going the entire this step like once, right? Now what we can do is we can pre-compute it, right? And so this is the answer, right? And I hope the answer is the same, right? Step 2, answer inquiry. So yeah, if you see, right, the answer is 17. Now since we have q queries, what we can do is we can pre-compute the answers, right? Instead of us having to do it, we can pre-compute what is the cost to go from this to this to this. Okay, so what I can do is pre-compute the cost. So I know costing, so if you see, right, from going from one step to next step, what is the cost that it takes, right? So if you see, right, just now that what we have calculated, it will cost us one step to go to next index. It will cost us one to go to next index. It will cost us how much to go to next index? 14. And what is the cost it takes to go to next index? This is 1, right? So we can pre-compute it, right? Like this is the cost to and let it say this is something like 0 or something, it be anything for the last, since it will never be, LNR is never same, so it won't cost, right? Okay, so if you see, right, this is the cost that it incurs to go from index I to I plus 1. Okay, uh, so what is this? This is left cost. So that says, like, cost it takes to go from index I to I plus 1. Cost to go from I to I plus 1. Cost of I in right direction, like this direction, right? So once we have this, right, so it takes this, and this. Now what I can do is I can pre-compute this. So since I need to find, okay, if I need to find from this index to this index, if I need to find from this to this, right, I will have to add all these values, like this value, this value, this value, this value. And whenever we want to add something, we already know we can use prefix sum. So I will just have a prefix sum calculated. So I will say 0, this will be 1, this will be 2, and 14 is 14 16, then this will be 17. And let's say if I want to go from here to, and let's say if I want to go from here, like not this, maybe yeah, this to only this, from here to here. So in that case, what I could have done is like this cost 17 minus whatever is the cost that we have occurred at this one, right? So I will just subtract the value of cost left minus 1, and we'll see like the cost it takes is 1 and this is 1, so we'll subtract it, so it will take 17 minus 1, which is 16. So this is what basically we're doing prefix sum. So this is for when we want to go from left to right. Similarly, we can also have one another way, another vector defined, which will just compute right to left, right? So in those cases where our in our query where our L to R is given and L is smaller, like let's say if you want to go from 3 to 0 or 4 to 0, in those cases we'll go from one step there, so there and like this, right? So we can have another cost which is called right cost. It will just it will be similar to this, just that we'll need to find if the closest is this, like this entire steps will be same, just that we'll calculate this and we'll compute the prefix here, right? So similarly we'll compute the prefix one here, and once we have this we can just pre-compute work on the query, right? So I'll just show the code, how do we do it, right? So this is the very first code, like we're getting the closest. So this basically the similar, like which is the difference. So this is just fairly simple closest code. Now the second thing is I'll have this left and right? Okay, and for I'm calculating this is the left cost. So pardon me if like this is not left cost, I should made it right cost, because we are going right? So if you see right, and this will say left cost, left move cost, right? So this is the right cost and this is the left cost. So okay, so this is the array. So what is the cost? We know, like it will take 1 unit if it is the closest, else it will take absolute difference of the two different values. Okay, so right of I is closest of if the closest of I minus 1 is I, then it will take 1 unit, else it will take nums of I minus 1. Okay, and we are also doing the prefix calculation here itself, instead of just having another array, prefix array, right? We are just doing the same thing here itself. We are computing in this right cost itself. Similarly, we'll have another for the reverse direction, like when I'm coming from left to right. And now I'll run the for every query left and right. If the left is smaller than right, then we'll compute it from this one, which is right of R minus right of L. And if this so in this cases where L is smaller, like this case, if you see 2, so in this case we'll have to come from this direction, right? 2 to 0, 2 to 0. So in this case we'll compute it from this left one, and we'll just put the answer in our result and we'll return it. I hope this was understandable with the example, but yeah, do feel free to reach out to in the